Let's look at our next application to economics, supply and demand. Supply is the quantity of a product that the manufacturer is willing to produce. Supply can be thought of as a function of the price P that the product sells for. We write this as S of P. S of P is an increasing function because the higher the price P, the more the manufacturer is willing to produce. That is, as the price rises, the manufacturer is willing to produce more of the product. On the other end, demand is the quantity of a product that the public is willing to buy. Demand also can be thought of as a function of the price P that the product sells for. We write this as D of P. D of P is a decreasing function. That is, as the price rises, the public is willing to buy less of the product. So far, we have found that supply, S of P, is an increasing function, and demand, D of P, is a decreasing function. Now let's look at their graphs. We can see here that S of P is an increasing function, and that D of P is a decreasing function. Suppose we set the price of our product too low, and the demand for the product is higher than the supply. Here we can see that the public wants to buy more of a product than the seller is willing to produce. This causes the price to increase. But what if we increase the price too much? In this case, the manufacturer is willing to produce more than the public is willing to buy. This leads to a surplus, and the price has to come down. In this graph, we can see that there is one price that the manufacturer is willing to sell the same quantity that the public is willing to buy. This is called the equilibrium point. We define the equilibrium point as the point at which supply equals demand. The price at the equilibrium point is called the equilibrium price, and the quantity at the equilibrium point is called the equilibrium quantity. Now let's look at an example. Suppose that the supply and demand functions are given by S of P equals 2P minus 4 and D of P equals 5 minus P. Then the equilibrium point can be found by setting S of P equal to D of P. Using the functions defined above, we have 2P minus 4 equals 5 minus P. Solving this equation for P, we find P equals 3. That means that the price we should charge so that supply equals demand is $3. But how do we find the equilibrium quantity? To find that equilibrium quantity Q, we have to evaluate either S at 3 or D at 3. In this case, we evaluated D at 3 to find that the equilibrium quantity is 2. So our equilibrium point is the point 3, 2.